Hello guys, my name is Desmond and I welcome you to my YouTube channel. So for today's lesson, we'll be looking at Physics Paper 1 November, exam paper of the year 2017. So we'll be looking at question 3, and as you can see on the screen of my tablet, we're given a statement there and you are advised to start this question on a new page. So it's in most cases where you're advised to start each question on a new page so that it's easy to mark your answer sheet, and again it makes your answer sheet neat so you don't have to confuse your questions. So without any waste of time, just before I get started, guys, if you are new to our channel, please do make sure to hit the subscribe button and the bell notification to be notified of future uploads. So the chapter that we'll be looking at for today, it's a vertical projectile motion in one dimension. So we're given a statement there. I'm just quickly going to read through the statement and just give you a bit of interpretation of that diagram that you see. So the statement reads as follows: stone A is projected vertically upwards at a speed of 12 meters per second from a height h above the ground. So ignore the effects of air resistance. We've got our first question, which says calculate the time taken for stone A to reach its maximum height. So I'll just scroll down so that you're able to see. So this given diagram, it's what I drew there. So it doesn't necessarily need to be 100% correct or the same. I mean, in terms of the dimensions, the difference between those two stones relative to the ground, as long as it looks more or less the same, then we're good to go. So from time to time, I'll be referring back to these questions on the tablet, and then I'll just be doing some calculations. So I will use, I think, that diagram to just quickly explain, and if there's something that I need to add on the diagram, I can just use maybe a different mark, to just add that information on that diagram. So without any waste of time, guys, our first question says calculate the time taken for stone A to reach its maximum height. So what actually happens on this diagram is, you can see we've got stone A, which is projected vertically upwards at a speed of 12 meters per second from a certain height above ground level. So that means that the projection of that stone A is actually projected vertically upwards at that level, or from a certain height above the ground level. So we are now required to calculate the time taken for stone A to reach its maximum height. So I think we should now get started with the question. I assume as we move along, you will be able to have an understanding of what's going on. So remember, guys, let me just quickly draw the scenario that we are actually supposed to calculate. So suppose this is H, this is the ground. So we are now focusing on stone A. Obviously, it's going to go up and reach a certain height. I assume you agree with me on that one. So obviously it's going to take a certain time as it goes up to reach its maximum height. So remember guys, almost everything that you throw upwards, it actually goes up until it gets to a point where its v final is equals to 0 meters per second. So the reason why as it goes down it decreases its velocity up to 0, it's because of the force of gravity. So the force of gravity is exerting the object thrown vertically upwards back to the ground. So that means for that object which has initial velocity of 12 meters per second, it will come to a stop after traveling for some time, and obviously when it reaches its maximum height, that's where its velocity is equals to 0. And what happens is that it momentarily stops, and then from there it's going to come down. So obviously in this case, as you can see guys, it won't just come back and stop at that point where it was projected vertically upwards. It will obviously continue to move down until it gets to the ground level. So now the question wants us to calculate the time for this stone to take, the time it takes to reach its maximum height. So this is the time that they want to know. So they just want to know how long will this stone A take to reach its maximum height. So what we know about its maximum height is that its velocity will be 0, and we're told it was projected at 12 meters per second. We also know that it experiences a gravitational acceleration of 9.8 meters per square second. Okay, so again we need to decide on the directions. So for this question where you've got an object projected vertically upwards, that's where you can take, for instance, up as positive, meaning down will be negative. Okay, so now we can have a look at the formulas and try to see which formula is going to be suitable for this question. Remember guys, I think on in the end of the question paper you are given this information, physical constants. So you can see your gravity there, you must use 9.8 meters per square seconds, and then now we need to choose the formula. So remember, these objects are moving vertically upwards, so that means in terms of changing direction or changing displacement rather, we'll be focusing on changing y because it's moving vertically upwards. But if it was, for example, a car moving, then we know it's moving horizontal, and that's where we use change in x. So let's see. For that question, we can just start there. Have we got the v final? Yes, we do. It's 0. V initial, we are given. This becomes g, and then change in time is what we're looking for. So that means we can use that formula in this case. So now let's do question 3.1. We know our formula is v final is equals to v initial plus g change in time. Okay, so now remember guys, velocity, it's a vector quantity, it therefore has a direction. So it's either you substitute your value with a positive or a negative sign. So in this case, because we assume object going up as positive, then it obviously means, remember guys, for its final velocity 0, either you assign a positive or negative sign on 0, it makes no difference. So we can just write it as 0. Even if you punch on a calculator and say positive 0, it's equals to, it's just 0. Even if you punch negative 0 and you punch it's equals to, it's still 0. So for 0, even in maths, you don't necessarily need to show the sign. You can just substitute as 0. So what is the initial velocity of that stone A? So it's projected vertically upwards at an initial velocity of 12 meters per second. And remember, because it's going up, then we say positive 12 meters per second. No need to substitute the units in the brackets. Then plus, what about G, the gravity? Is it going up or is it going down? We know at all times G is going down. So now because we use downwards as negative, then we substitute it as negative 9.8, close, change in T, which is what we are calculating. So it's just a matter of you moving that to the other side. Then it becomes negative 12, which is equals to negative 9.8, change in time. Then you can now divide by negative 9.8 on both sides, so that it cancels, you remain with change in time, which is what you're calculating. Then you can punch this on your calculator. So you can now pull out your calculator and say fraction button, negative 12, use the arrow to come down, it's negative 9.8, which is equals to 1.22. So that means it takes 1.22 seconds. That is the time that it takes for object A or stone A to reach its maximum height. So I assume you understood. This was a straightforward question and a straightforward answer. So now remember guys, this question is allocated 3 marks. So I'm just going to show you exactly where you score your marks. Luckily, with this question, you're most likely to be given a mark just to choose the correct formula. And again, before I forget guys, there are a lot of ways in which you can answer questions related to vertical projectile motion in one direction. There are a lot of ways. So this is not the only way in which you should solve this particular problem. There are multiple ways. So I only show you the simplest ways so that we don't lose each other. So we give you a mark for choosing the correct formula, and then we give you a mark for correct substitution, and then we give you a mark for correct answer. So I assume at this stage guys, we are still together. Otherwise, if you have questions, you know what to do in the comment section. So I think we can now move to question 3.2. So I'm just having a last check just to confirm if I've missed anything, but otherwise so far so good. I don't think I've missed anything. Thank you guys.